with the Villa circle. We have already progressed up to problem number 18 in fluid statistics. Now the next problem will come is problem number 19. Okay. So 19 says two pistons of a hydraulic machine have diameters 20 centimeter and 2 centimeter. Find the force exerted on the larger piston when 50 kg weight is placed on the smaller piston. When the smaller piston moves, through 50 centimeter, by what distance the other piston out. Now let me draw the simple diagram of it. There are two arms of the hydraulic machine, one having higher cross section. This we can say the load arm, where the load is being carried on it. This is your load, okay, and the load is what is said, the larger piston when 50 kg is placed on the smaller piston, and this is smaller piston on which a force is being given. That force is equivalent to 50 kg weight. Okay. The diameter of it, small d, is 22 and capital D is 20 centimeter. This is centimeter. The thing will move. The smaller one will move for 50 centimeter, and the bigger one will move by, let's say, h. This is unknown to be calculated, and the force exerted on the larger piston. Find the force exerted. So that means this is the force exerted on the smaller piston. Due to that, there will be a force which will act on this. Let's say this be the F2, this is F1. So you have to find the force. So there are two things to be calculated. One is the force exerted on the load arm, the piston, and due to the force. So as you know, there are two theory: energy conservation. That means energy is being conserved, conservation, This is one part, and second is volume flow rate. Volume flow rate. Both are constant. Energy consumption, this is also constant. There is no change in energy input or output. This is also same, constant. Okay, this is not changing. The first thing is that if I consider the force F, which is because the displacement we don't know, so in that case that force arm, which is the after putting the force, after the piston is under equilibrium, so whatever pressure it is created by the force F1 will get here as reflected here when it is F2 is exerted. Okay, so my force on the smaller arm, if I say this is F1 and the cross section is A1, that must be equal to the F2 force exerted on the higher arm, and if I divide with its cross section, I will get equal pressure, because what is that P1 pressure here, it is P1 P on here, it is P2 at any horizontal line, this P1 is equal to P2. This is the first and foremost pressure in a system which are in equilibrium. So we can assume this under the force, when the liquid is in equilibrium, then everywhere the pressure is same on that concept, and this pressure is nothing but the force exerted by the cross section, force exerted. Now from this, force is 50 kilo weight, I am keeping it same, and the cross section is, it is a piston, that means it is around itself, hydraulic machine, we can assume this is, and it's because this is said to be the diameter, so it will definitely be done. So pi into d square is 2 square by 4 will go up. Okay, this is equal to F2, we don't know, that has to be calculated. F2, A2 is pi d square, for this case 20 square, and 4 will go up. So the equal things can be cancelled, because this will not participate or change any value in the calculation. So what is your F2 is equal to 50 into 20 square means 400 upon 4. So this will cancel, we will get 155,000 kilo weight. So 5,000 kg of force it will be exerted. This is the force in 50 kg. You can kg force, you can say the kg weight, you can say that 50 kg is exerted there, and this 5,000 kg force will be exerted on the first part is find the force exerted on the larger arm. This is 5,000 kg, kg force you can say. Okay, this force is exerted. The first part is over. For the second part, you have to find the displacement of the arm. So displacement of arm can be getting from this. Okay, so how will you get the volume flow rate? The cross section A1 into the height, the displacement, the volume flow rate of the liquid, it must be same as the cross section of this arm into the height raised H2. Now out of this, H2 is not known. So what is your H2? As let's be H2. So A1 pi into d square by 4 into H1 is how much? 50, and A2 if I take, it will come down as a denominator here, 5 into 20 square into 4 will be there. So 4 pi 5. So 2 square 20 square is 100. So that means equal to half of centimeter. So 0.5 centimeter will move up, isn't it? This is 2 square means it is 400. 4 will cancelled out. 50 by 100, that is equal to half. So the second answer, by what distance the other piston will move, this is half a centimeter. Understood? Okay, move on to the next problem. the next is number 20. A stone of density 3000 kg per meter cube is submerged in water if the mass of the stone is 30 kg. Find upthrust. So, if I want to represent it in a figure, so this is something like that. Is a water bath, or is a water inside a container, and this is surface, and a stone, let it be uniform size of a round shape, is submerged. So this is dipped into water. So as per the definition, what is upthrust? Upthrust is equal to the weight of the fluid dispersed by any object dipped in a fluid is the upthrust. So this is as per the Archimedes principle. We know the what is the upthrust. Upthrust is nothing but if an object is dipped in a fluid, how much volume the object can disperse. Sometimes it may be possible. In theory, you have already done partially or fully. In whatever condition, the volume occupied inside a fluid by the object, and if I take that volume and then convert the equal amount of volumes weight of that fluid, it will be equivalent to the upthrust. Fine. So if I go with the statement of the theory, that means if the object, if this case is the stone, is submerged, so that means it is dispersing equal volume of liquid when it is dipped inside. So what would be the volume dispersed, which is nothing but the weight of the solid divided by the density of the solid. So weight of the solid is 30 kg and the density is 3000 kg per meter cube. So this is nothing but 1 by 100 meter cube of volume. The liquid dispersed. So what is the weight of the fluid? That means this case is this water. This is nothing but the volume of the fluid into the density of the fluid. Now the volume of the fluid is equal to volume of the solid. This is the volume of the solid. This is equivalent to the volume dispersed, volume of the solid, into rho F. The volume of the solid is 1 by 100 into the F, the density of fluid. Here the fluid is water. The density of water is how much? 1000 kg per meter cube. This is standard one. So we can take 1000. Now it will come as kg of water. So this is nothing but 10 kg of water. So now how much force is exerting? This is 10 kg of the weight of the liquid is 10 kg. So then force, if it is in kg force, now that force will be 10 kg. Okay, so now if I want to convert into Newton, so you have to further multiply with 10 approximate, because this is 9.81, you can take to 10, it will be this much of Newton. So force, this is the bound force, that will be 100 Newton of force, or 10 kg force of buoyancy. It will be the amount of buoyancy or upthrust, whatever you say, will be the value of the upthrust. Okay. So we'll move on to the next problem, that is problem number 21. The problem number 21 says an iron cube of mass 5 kg and side 10 centimeter is suspended by a thread in water. Find the tension in thread. Okay, so diagrammatically I have to represent this. Now this is some fluid. The fluid is said to be an iron cube is a mass of 5 kg and the cube is suspended by a thread into water. So this is water. So this is cube. Okay, so this cube is being suspended from a string. It is supported at some point. Okay, so now we have to find the tension. The tension will act upward T. So what are the forces acting on this? The body weight, this is weight of the solid, and the upthrust acting on the body. So if I say this is in perfect equilibrium unless there is a condition that string itself breaks, okay, or the body itself moving up with the additional force, unless until it is in equilibrium. So you can say that tension plus the upthrust, which are acting upward, must be equal to the weight of the solid. So now as it is submerged, so the tension plus the buoyancy, the weight of the fluid dispersed by the solid, it will be the same. So then T is equal to nothing but weight minus weight of the solid minus weight of the fluid. So in both cases, weight is equal to what? Volume of the solid, rho of solid into G, minus volume of the fluid, rho of fluid into G. So now Vf and Vs are same, as because these are submerged, as body is fully submerged. Okay, we can say. So now we can take this and this common. So V and G will out Vs rho s minus rho f. Now the iron cube of mass 5 kg, side 3 1. So V you can calculate. This is side. We can calculate suspended string. 5 kg is the mass. So mass of the solid is 5 kg. 5 kg. So rho of the solid is nothing but 5 by the volume. Volume is what? This is in centimeter. So centimeter cube, and from centimeter when it will move on to meter, have to divide by, this is centimeter. Rho is what? Mass by volume. So I have to convert into 10 to the power 6 centimeter to meter, 10 square cube, that much. So this will be the 5 into 10 to the power 3 kg per meter cube. This is the solid, and the liquid is water. Water is equal to 10 to the power 3 kg per meter cube. So now put this value. V we can take as V is equal to 10. So 10 to the power 3 is the volume. Now converting into meter cube, 10 to the power 6. What is your G? G is 10, you can take meter per second. And this is 5, 10 to the power 3. And it is 1 into 10 to this is, that means ultimately 4 into 10 to the power 3. So everything is there. So tension will be in Newton. It is a force unit. So if I cancel 3, 6 cancelled, so this is equal to 40 Newton of tension will act on the string. Understood? So here we will stop this episode. In the next episode, I will move it from number 22. So thank you for now. Good night.